Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about how to classify triangles and our triangle angle sum theorems. So whenever we classify triangles, we're pretty much just using two words to describe them. So just think of people. You can describe someone's interior, like their personality, but then you can also describe their looks. Like you could say, oh, she's really sweet and she has dark hair, right? That's inside and outside. We can do the same thing with triangles too. So angles would be our inside words, and sides are considered our outside words. So one of the ways that we can describe the inside of a triangle is by the angles, and if all of the angles are congruent, that's called equa, like equal, angular. So that's if all three angles are congruent. And I'm going to abbreviate, and I'm going to do the angle symbol. So all three angles, I'm going to do the congruent symbol. So that just means angles, and that just means congruent. So if all three angles are congruent and a triangle adds up to 180, then 180 divided by 3 means that each angle will equal 60. The other way that we can describe a triangle is acute. Now, if you remember, acute means less than 90. This would be if all three angles are less than 90 degrees, and that's all of them. If one's big, it's going to change things. But if all three are small, so if all three angles are less than 90 degrees, that makes our triangle acute. And you probably heard of right before. Right means 90 degrees, but in a triangle, you can only have one angle that will equal 90 degrees. So that's a right triangle, is if one angle equals 90 degrees, which leads us to obtuse. Now, if a triangle can only add up to 180, and obtuse means more than 90, well, think, if I have 180 and I split it in half, if one angle is taking up over half of it, the other ones are going to have to be small. So an obtuse angle is if one angle is greater than 90 degrees. Keeping in mind that one of the angles will be greater than 90, but then the other two angles will be acute. And those are our four inside words. Now for our outside words, we have equilateral, isosceles, and scalene. And you probably have heard of equilateral before. Equilateral is if all three sides are congruent. So that would be if one side's 8, all the sides are 8. Isosceles would be if at least two sides are congruent. And I say that because an equilateral triangle is always isosceles because it fits that definition. At least two of the sides are congruent, but isosceles triangles are not always equilateral. So equilateral is when all three sides are congruent, and isosceles is when at least two sides are congruent. So scalene, you could probably guess, is whenever there are no sides congruent. So that'd be like 3, 4, 5, 6, 8, 10. If all of your numbers are different, that's scalene. So if I take a look at this picture, we have a lot of triangles in here. What I want to know is how many can you classify? So if you take a look at this lime green triangle, I would call that triangle ABC. And to name triangles is just real simple. It's the triangle symbol and then it's the 3 points in the triangle. So triangle A, B, C, and then I would actually close it out because this is a triangle, not an angle. So that lime green triangle, if I see these double ticks all the way around, remember that ticks mean congruent. So that's saying that all the sides are congruent. So I could say that triangle ABC is equilateral. And if all the sides are congruent, all the angles are congruent. So I could say that it's equilateral and equiangular. And if I see the blue one's also equilateral and equiangular. I see ticks right there. Now let's take a look at this white one. So if I trace it from A to C to D, and I'm going to go back to A because it's a triangle. I see that two sides have matching ticks, but the third doesn't. That makes it isosceles. So triangle ACD would be isosceles. And if I look at the angles, I notice that one, remember 90 makes an L, and that's over it. That's bigger than 90. So that would be obtuse. But just like any obtuse triangle, those two smaller angles are going to be acute. Now I also see on here this box, and if I kind of trace the box, if I make an L from the box, and those are called legs of a right triangle, I kind of see I do have a right triangle from A to C to E. So triangle ACE is our right triangle. But remember, there's always two words that we could use to describe it. So back up here, I used right, but now I need to pick a word from down here. And if I trace it again from A to C to E and then back to A, I notice I have one tick, two ticks, no ticks on that side, which means that none of the sides are congruent, so we could call that scalene. So taking a look down here, I want you to see, can you figure out what these are? You can go ahead and pause the video while you take your guess. Remember that you're going to pick one from up here, and then you're going to pick one from down here. So go ahead and pause the video for a minute so you can just look at those triangles and see if you could take a guess as to which one is what. Okay, so hopefully you paused the video. If I take a look at this first triangle, at a first glance you might think acute because all of the angles are less than 90. But there's a more specific word that we could use for this. There's a better word. While all the angles are less than 90, they're all the same number. They're all 60 degrees. So I could call this equiangular. And then if I take a look at the sides, all the sides are the same number, so it's also going to be equilateral. And I like to work my way from the angles to the sides, so I like to go from in to out. That's just me. If I take a look at this next one and I look at my three angles, I can see that they're all less than 90. So this would be acute. And then if I take a look at my outside numbers, they're all different numbers, which would make this scalene. Now, this is a great picture that shows us this thing called hinge theorem. And you can write that down if you want to. So this shows us hinge theorem. Hinge theorem says that the small side is across from the smallest angle. So if you have 44 and 57 and 79, that would make your smallest angle 44. Well, what was our smallest side? 6.1. And notice that they're opposites. They're across from each other. Also notice that the biggest angle is 79 and the biggest side is 8.7. Notice that they are across from each other. They'll never be adjacent. They'll always be opposites. So they'll always be across, and that's called hinge theorem. And we could see that very clearly in this right triangle. And I know that it's a right triangle by 90 degrees. And in a right triangle, we have a special name for the longest side. The longest side is called the hypotenuse. And in this case, our hypotenuse is 13.2. Because in a right triangle, the hypotenuse is always across from the right angle. It always is going to be the biggest number because 90 will always be your biggest angle. But going back to the question at hand, this would be right and scalene because all three numbers are different. But we can very clearly see hinge theorem with the hypotenuse. We can also see that 32 is the smallest number and 7 is the smallest side. And notice, once again, across from each other. And then on this last one right here, my first thing is I see 128. So I see an obtuse angle. And if I check that obtuse angle, I notice that I see 26 and 26. I notice that the acute angles happen to be the same number on the inside. So I could put some arcs here if I wanted to, because remember arcs show congruent angles. And then if I look at the outside, I'll also notice 2.5 and 2.5. So 2 angles were congruent, and so were 2 sides. And that's because there's a pattern between our angles and our sides. And remember, if 2 sides are congruent, this would be isosceles. Now, in any isosceles triangle, you're going to have 2 things that match and 1 that's the odd one out. In this case, 4.5 is the odd side out, so we call that the base. And of our 3 angles, 128 is called the vertex angle. And that's because 4.5 is the odd side out, so that's our base, and 128 is the odd angle out, so that's our vertex angle. And then from there, what we call our other parts is we call these congruent angles. The ones that matched are called our base angles. And then our sides that matched are called legs. So in an isosceles triangle, you'll always have 2 that match and your odd one out. And so we have specific names for those sides and angles that match. What we're going to talk about next is how do you find these angles? Like taking a look at this triangle, how would I find X? How would I find this angle right here? How would I find that information so I could actually classify these triangles? And that has to do with our interior angle sum rule and our exterior angle sum rule. And you probably already know the interior angle sum rule, and that's that all 3 angles in a triangle sum to 180. But it's the interior angles that sum to 180. So you can clarify that if you want to. It's all 3 interior angles. And if you remember, interior means inside. So those are my 3 angles that I would have on the inside. Our exterior angle sum rule is a little bit different. Our exterior angle sum rule says that to get the exterior angle, it's equal to the sum of your 2 remote interior angles. And you might be thinking, what a remote interior? Well, if you think of a remote island is far away. That's what remote means. It just means far away. I like to think of it like this. If you're looking for the remote, it's typically far away. It's always on the other couch. It's always on the other side of the room. Just remember that remote means far away. Or you could think in geometry terms and say not adjacent. It's not close by. We're going to do some examples in the next video, so make sure that you have your calculator handy. See you in a bit.